And I want to hand things over to Mark Sokol, who has been relatively quiet recently. So you've got some updates for us today, right?
Yes, I do. I just need to share screen. 1 second. Maximize this. I'm going to give a update. This is also for last 2 weeks ago. Jeremy Reese, Travis, and Aiden Schaefer were down here at the lab. We just had so much going on. I couldn't concentrate on APEC to give you guys an update. So this is like a 4-week update on what was going on. And I'll just do it in pictures over here. Okay, can you guys see that? That's a 3-roll mill.
Yeah, it looks great.
Yeah. Okay, so yeah, this is a piece of equipment that arrived a couple of weeks ago. This is for making really fine powders of similar size. Oops, let me see what's going on here. I'm trying to. Okay. So this is Tom Butler. He is a local dude who helps out in the lab. And we started work on the Alzaphon waveguide for the dynamic nuclear orientation experiment. And here we are putting it together. Basically, it starts off with a circulator with a dummy load over here. And then these are 2 isolators. Basically, this is all for reverse signal filtering to make sure that the any bounce, standing wave doesn't end up inside our klystron, damaging it. And then we have a cross guide, which basically tells us forward and aft power. And it ends off over here with a filter. Now, the next thing we did, I met up with Aiden Schaefer over here, and we flew into Chicago to check out this CNC machine that I found on eBay. We were shopping around for a CNC machine for the lab for quite a while, and there's been a lot of demand recently. And this was a sweet deal. It came with everything, like all the tools, tool holders, the bench, the vices. It came with everything. It was the whole caboodle, as Mike Gumbel says. And here it is all packaged up and stuck on a truck. And then, oh, there's Tom again. And this is, what was his name again? Oh, Sam from this is a kid I met on APEC here, and he promised to come down to the lab and help out. And he sure did. We are getting the machine ready to take it inside. And we had to bring these riggers in order to actually bring it into the building, because there was a problem with the forklifts. One was too big to fit in, and the other one wasn't strong enough to lift it properly. So they came down and did the job and stuck it in the corner for us. Oh, and then these guys came down. This is Kevin Knopf and Keith from the University of Albany. They head up the physics department over there. They came down to check out the lab. Keith actually is an EPR expert, and he's never heard of the Alzaphon experiment before, and was pretty interested in it. One thing he did note, though, is that the Alzaphon experiment requires pulsed EPR. He said EPR machines don't have a pulsing option. They're just continuous. And yeah, he's never read anything about weight changes inside of a EPR chamber, which would be pretty hard to detect because you'd have to actually take the chamber apart and make holes in it. But he's very interested in this experiment, and will probably be coming down here when we're ready to run it. So this was one of the first things that I made on the CNC machine. We got all Fusion 360 and the tool paths, and here's how it came out. Cut that out on what is that, 6061 aluminum. The guy also gave us a whole bunch of stock aluminum because he wasn't going to be doing any manufacturing anymore. So we got like a whole package deal. It was really awesome. And then Aiden Schaefer came down to the lab again, and we're just getting organized over here, building the toolbox. This guy, Aaron, showed up. He shot a documentary film. Yep, here we are out in the parking lot, and look who showed up. That is Travis and Jeremy Reese. They drove down in this truck. He covered it with graffiti. The alien scientist disclosure now. My other vehicle is a TR3B, declassify everything. Jeremy was getting all different kinds of girls on the highway were honking at him. It's pretty cool. Here's this was 2 weeks ago when he was down here just getting the stream ready. Everything happened last minute. He showed up literally right after APEC started. Oh, and then this guy Aaron did interviews for his documentary. Oh, and this is at the lab house. So we do have a house, a guest house. It's a 5-minute walk from the lab, and everyone was staying there. This was at breakfast. And here's a picture later on. Me and Ada were working on the waveguide for the Alzafon experiment. That's the end piece where the coherent waveforms are supposed to happen. We started off by trying to mill out the copper, and then decided to just go with sanding and buffing. This was an end piece that I actually had to cut using the CNC machine, so that worked out pretty well. That's the end device that's like the attachment grommet. I reinforced it with lots of copper on the side because it's going to be holding quite a load when it's finished. And here he is buffing it out. Okay, this was our ARV coil. Jeremy probably remembers this. After he was down in, I think, Washington, D.C. by Tim Pool's show, he came up to the lab and we wound this coil together. It was a couple hours. The plan was to cover it with epoxy to then be able to stuff as much voltage in there as possible without it arcing over. This is an experiment we call Easy Alzafon. It's basically the core of the ARV coil. And we're prepping it, in this picture, we're prepping it for a potting with epoxy. Oh, this is the waveguide end piece. So I plated it in gold. That's the plating setup. Blue Moon really helps. Okay, and this is the coils inside of our vacuum chamber. The reason why we stuck it in a vacuum chamber was to remove all the bubbles. And we actually pulled a vacuum and pushed it down again several times in order to get all the bubbles out. It didn't end up coming out perfect, and I'll show you that in a little bit. Then we stuck it on a CNC machine to sort of guess and pull take all the material out that wasn't the coil. I ended up, this is what it looked like while it was cutting. And oh, here is the waveguide end piece. As we were soldering it, this was like a 2-man job. We needed to hold it from all different angles. Soldering it was using 2 torches. We had 2 torches going at like an X formation in order to heat up the copper. Copper is such a good conductor of heat that you really got to heat the whole thing up for a while in order to get solder to run on thick. That's like 1/4-inch plate copper there. And going back to this, the coil, this is the finished coil. We pulled it off of the, I had to pull it off and clean it up. I'll show you those pictures later. These are all in synchronous order based on time. So you'll see it as it happened in the lab. Here is the completed setup with the klystron, stuck in, going all the way inside the electromagnet over there. You can see it from the other side. And here's Aiden smiling. Oh, and then we got some aluminum blocks over here. That's for a later experiment that I'll get into a little later. Basically, we're trying to make a waveguide. That's for a later experiment. We're trying to make a waveguide that's going to be in the shape of the hull of the craft and have the magnetic field lines create sort of a homogeneous field homogeny based on whatever magnet we have in the center, and that would sort of create a flying saucer shaped craft. And to do that, we're going to use 2 big blocks of aluminum as dies and basically pound another piece of thin aluminum plate in between those aluminum blocks. That's what you're looking at over here. And here is the finished ARV coil. There was some damage to the inner lining, so I had to remove some of the bad wires from the center, but this is what we were left with. I then cleaned it up again and epoxied it again just to clean it up. And here is the finished product. It's actually sitting right here next to me on the desk. Okay, the next thing we did was started working on the field homogeny for the electromagnet. Now, last time I spoke, we had this idea to use a 3D printer to map the field. Now we're still going to go with that project, but it wasn't ready, and I just wanted to move forward with this. I created this grid system with 2 line lasers that are at 90 degrees to each other, and a grid system of ABC 1, 2, 3, and then I stuck a probe in with a 90-degree cut on it. So it will basically cast a shadow onto the grid, and I'll be able to say K7, you know, this is the result, and stick it onto an Excel sheet. And this is the mapping of the magnetic field. This is what we ended up with. Now, using this, actually this line over here, the one that goes all the way through the magnet, I was able to extrapolate basically a field strength graph, and use that to create these lenses, magnetic lenses. The first attempt was done via the 3D printer using a magnetic iron PLA plastic. And here's one of the first attempts at it. That's the, these are different discs that I made, and then we went with a thicker one because the correction wasn't strong enough. Then it was too strong in the center, so I cut out kind of center hole. And basically what we ended up realizing is that the iron that's embedded inside this iron PLA plastic wasn't strong enough, so I had to go with just pure iron and CNC it out. The next thing that happened was we got flooded. So the shop is in a flash flood zone, and it's actually equipped with these floodgates. So this is not the amount of water that actually made it into the shop, but we're up against a stream, and situations like this can happen every couple of years. It's about 2 feet of water there, and it's gushing past. Like, this is whitewater rapids over here. And this was the situation for about an hour, about 2 days ago. And oh, here's inside the lab. We got like 2 inches of water over here, and this is right after it. You can see over here, these are the floodgates. Luckily, the only thing that could have possibly been damaged, because I intentionally did not leave any equipment on the floor. Everything was just, you know, dead items. There was an oscilloscope on the floor, and thankfully it was not damaged. So here is the metal blocks that I got for the lenses for the magnet, and we're cutting it out. This is the tool path. Lots of fun figuring out how to cut the tool path properly and how to adjust it. There's so many freaking settings in Fusion 360. You know, it's a real challenge figuring them all out. This is one thing that I learned is if you're cutting, you want to cut below the stock, you got to use stock to leave and then -1 millimeter. It's a little trick if you want the tool bit to go underneath it. So basically, this was attempt number 1. We broke a bit because the speed rates were way too fast. The whole machine was shaking when that happened. The next one, the bit did not break, but it didn't go deep enough to cut out the piece. And this is the third one where it just about got deep enough to cut out the piece, and I had to do some work by hand. That is the end result of one of the pieces. And I actually, during the conference, we actually were running a second one. They are right here. And these are going to be magnetic lenses to correct for the anomalies, the issues that we were seeing with the magnetic field's homogeny. Good thing about it is, you know, I could change these out as little inserts against the magnetic field plates, and then we can see, you know, how that correlates with the magnetic field readings that we're getting. And here is the scope that was on the floor. This sat in about 1.5 inches of water. It was inside a box though, so it might have been floating, but thankfully it survived. So there was no damage in the lab. We got 2 big ass dehumidifiers in here right now. It's actually pretty dry. And the debrief wrote an article about me. And they made it all about a warp drive detector, or the laser interferometer thing that we are talking about a couple of months ago. And I explained to them that it's not a warp drive detector, it's a laser interferometer, but yeah, they just wanted to call it something more exciting. That's it.
That's a lot, Mark. That is a ton. That is a ton. So how have things been going other than that? You guys got flooded. You have a ton of new equipment, a ton of new experiments. Everything's moving along for you.
Yeah, I mean, it's very exciting to having the CNC machine really is a game changer. I wanted to hook up with Brian St. Clair and try building his device. Right now, it's just like a push button away. We can build one of those things pretty easily. We actually have a 4th axis on that machine. So if he wants to make one of those fancy gears with the slanted grooves, it could do that as well. But it's the main, the only holdback would be the CAD files and the materials you want to work with.
Those aluminum slabs that you showed in the photo, they're big. You know, are those solid or are those like hollowed out? Those are solid?
No, those are solid. Yeah, those are 4 inches thick, 12 by 12 slabs of aluminum. They weigh quite a bit, even out of aluminum. They weigh quite a bit.
I was gonna say that must be super heavy. Yeah, I was looking at those going, that can't be solid. Well, should we go to open discussion now?
Sure, unless anyone has any specific questions about my presentation.
Well, and you know what? Here, I'll go to gallery view. Everyone give Mark a hand. Well done and detailed update. Well done and detailed update.